Scholar, section 2.3 is about the property of functions we call continuity. So you probably have already used the word continuity in your real life, and it means in math sort of maybe what you'd guess. A function is continuous if it doesn't have any breaks or gaps. Informally, we say that a function is continuous at any place if you could draw the function near that input value, near that x value, without picking up your pencil or having to skip over something in the graph. So just for example, this is the problem, this is the graph, a function that we used back in section 2.1 to discuss limits. Let's talk about the continuity of this function. So imagine this, we're just going to use this sort of informal definition of continuity. Could you draw this graph without picking up your pencil? So you could try, we could start right here at x equals 0. We could start here at x equals 0, and we could try to draw along it, and that works until right about the time I get to the place where x equals 1, I can't continue. I have to pick up my pencil so I can jump up here and pick up the graph right here. So this function is not continuous at x equals 1 because I had to pick up my pen. I could keep going. This function, I could start up here at 1 and keep drawing toward the right. Something happens again when I get to x equals 2. This is a little bit different. There's a hole in my graph. It's only a teeny tiny 1 point wide hole, but it's still a hole. I can't draw that. I can't draw through the hole because the graph doesn't have a hole in it. So again, I've had to pick up my pencil. So I could continue on after that, and I can see that I could draw the rest of this function without picking up my pencil. So for the whole domain of this function, which is from x equals 0 to x equals 4, this function is continuous because I could draw all of it except at where x is 1 or 2. So here is an answer to your question, and we read this. I would say this function, f of x, is continuous for every x that's in the interval. This little guy means is an element of, or is in the interval of, 0 to 4. I have brackets because 0 and 4 are endpoints that are included, except for x equals 1 and x equals 2. So I want you to stop the video now, and I want you to answer that next question on your page. I told you for what x values this function is continuous. Now for those two x values where it's not, x is 1 and x is 2, I want you to stop and figure out the limit as x approaches 1 from the left, the limit as x approaches 1 from the right, and the limit as x approaches 1 of f of x. And then do the same thing for 2. I want to start to make the connection between this graph and a formal definition. So there are different types of discontinuities, different ways a function can be discontinuous. I'm going to ask you to label those 3 graphs at the top of your page, your notes page. So one type of discontinuity is this one where I have a hole. So here I could try to draw along here, but I've got a hole. Here, again, I have a hole. This hole happens to have a function value filled in somewhere else. So whether there's a function value or not, if I have a hole, one single point that's missing from my graph, that's called a removable discontinuity. Removable because later we're going to learn that we can remove the discontinuity. We can make the problem go away by filling in the hole. And there are 3 more kinds of discontinuities that all form a category of discontinuities known as essential discontinuities. Essential meaning it's built into the graph and there is nothing you can change that could make that discontinuity go away. So one is a jump discontinuity. If I approach one value from the left, but from the right, I was trying to approach a different value. If I'm trying to draw with my function, I actually have to jump to a different y value as a jump discontinuity. An infinite discontinuity occurs where I'm approaching a certain x value, and here I happen to go up and up and up and up and up. I'm never going to be able to cross over to the next branch of this function because this branch is going to continue infinitely high. So if the limit as I approach a certain x value from the left or the right is infinity, I will probably have an infinite discontinuity. There's one other type. This is a discontinuity that can occur with an oscillating function. which you won't actually have to worry about in calculus AB or BC or even any other calculus that I know.